myself. As you can see, my name is Srikant Ramachandran. I was born in Tamil Nadu, and then after my undergrad in NIT Trichy, I did my masters, went to Australia, and then spent 15 years in Australia, and then went to US in 2006, and I'm there. Right now, I'm in Chennai, just on a vacation. So happy to meet with you all. And throughout my career, I've been specializing in networking. And for the last decade or so, more into cloud, AWS in particular, and cybersecurity. Today's topic is about uh, agentic AI systems and cybersecurity aspect of it. We all know that this whole generative AI and agentic AI is taking the world by storm. And so it's important to understand the cybersecurity because everybody talks about what it can do, but hardly anybody talks about the risks there. So this is a cybersecurity focused talk. So we are going to exclusively cover that. And my reference for this discussion today is this finding from the red team of NVIDIA. I don't want to read this word for word, but essentially, a red team in any company, they do the offensive work, meaning they try to penetrate into an organization's defense. The blue team responsibility is to catch it and stop it. So it's a red team, blue team kind of a thing. So this is NVIDIA. So highly reputable team. And of course, they make GPUs, which is predominantly used in so many data centers for all the LLM models. And so this is kind of a summary of what this team found out. And I'm hoping that you will learn some things. Of course, I strongly encourage you to go through this presentation, which covers it in a lot of detail. It's almost an hour, and it was presented at the Black Hat conference late last year. So it's very recent. Let us go through some definitions. So we all hear about agents. So what do agents do? So far we have never had this kind of a moment, or at least in the last year, where devices take autonomous actions, and the level of autonomy they have varies from, you will see, from level 0 to level 1, as the NVIDIA team categorized it, level 0, 1, 2, and 3, which we will see what they do. So because it's important to understand these levels before we go into the risks of agentic AI. So let's take it one level at a time. So level 0. What is level 0? So it's a very, very straightforward question and answer type of a thing. I ask a question and it gives an answer. Very simple. And of course, the LLM has been trained on a vast source of information, but essentially for one input, you get one output. Second input, second output. Almost like, think of it like a Google search. You put one search, it gives one output. You change the search, it gives another output. Now, in level 1, what happens is it remembers the conversation. It remembers the context. So think of ChatGPT here. So we start with a question, and then we give more context as we go along. And it remembers that context in its memory, and then it modifies subsequent responses. It doesn't go back and modify previous responses, but it modifies subsequent. So for example, I may ask a question, it may give generic information. Then I will say I'm based in California, then it will give something specific. Then I may say I'm working in IT, then a third kind of. So it remembers the context. So that is level 1. So we are really, so the autonomy here is more of its ability to, go through information and give us, understand the natural language, and then give us a response. In level 2, and I have a diagram next slide in terms of what the level 2 looks like. It's easier to visualize rather than say it in 1,000 words. So it has a level of discretion. So it has a bunch of tools. So all these agents are equipped with a system prompt, which is where you tell that what it's supposed to do, something like you are an agent that specializes in this, so that it knows what its role is. And then it also has a bunch of tools that it has access to pull the necessary data. Of course, it was trained on open source information, but then you may have some specific tools, which is local tools developed that it can use to craft a response. And then it's not necessarily one hierarchy. You know, the output of the tool can then be fed into another LLM, which gives more output, and eventually the output comes back to the user. I'll pause here after this, maybe after a couple of slides, and then you can ask some questions. Okay. So level 3 is when this is kind of the agent that we hear about in the news, where everything is autonomous. So you give a task. It's not a question. You give a task. It then does all the research. It's almost like a little human, an assistant, right? So it does all the research. It then plans the whole set of actions to take, and then it gives a output. So Claude Research is one example, as I call it. Even IDE's Cursor, which we will use in the course, upcoming course in a week that I will talk about later. It has an LLM integration, which is partly their own LLM and partly it relies on public LLMs like GPT-4 and so on. But they all have a level of autonomy in terms of being able to insert code, modify code, and all that. This is a scary part. At this point, in level 3 alone, I give it a task and I'm just hoping and praying that it does the right thing. I don't want to make it sound scary, but it's kind of scary. As humans, we all want to know what is going on. We wrote the code, or somebody in the team wrote the code, which we can go and ask explanation, whatever. But when something happens by itself, there's always a healthy doubt that we must have. And that is level 3. Okay. So just to go through level 2 and 3, level 0 and 1 were straightforward. Level 2 is like this, right? You have an input at the very left, and then that launches, it makes a discretionary call saying for this question, because it's trying to understand a natural language question. And then it says, okay, I have these two tools. I'm going to use either the tool on the top or the tool on the bottom. Let me try to annotate. LLM, and it can, based on its discretion, it can use the tool on the top or the bottom. The output of that tool is fed into the LLM again, which could launch another tool, or it could launch another LLM, whatever. And finally, the output comes through. So there's a level of autonomy in the sense that it makes a choice of whether to use this or this, whether to go this way or this way, wherever, right? So that is level 2. In level 3, this is the where it is planning, it is executing, and there is a cycle. There's a feedback. So initially the input comes in, it uses a tool or whatever, and then it goes back and feeds itself back to this LLM to keep going round and round like an iteration. And finally, the output comes. So it is in this iteration, there is a lot of concern, if you will, in terms of how well it is doing. Is there credible reference? Is there an explainability to it? Because human nature, when it works well for the first, say, 10 times, we automatically believe that it is doing the right thing the 11th time. Maybe, maybe not. So that is where this level 3 concern comes in. As I promised, I'm stopping now. Any questions?
ஹலோ ஸ்ரீகாந்த்.
சொல்லுங்க, please
இல்ல
go
இல்ல,
ahead.
எனக்கு நான் தமிழ்ல இங்கிலீஷ் தமிழ் ஏதோ ஒன்று எனக்கு என்னன்னா, just explain me in level 2 level 3, is it any real time explanation based that is easy to understand? Example, if ChatGPT is there, I said just rewrite that statement, means it will rewrite, that is level 1. So like consider like that.
So in level 2,
Yes.
so if you go back here, so we must always think that in agentic systems, it has access to some tools, maybe an internal homegrown tool, right? That will make a web request or something like that. And based on the output of that web request, it won't have the direct answer, but it will have an input to the answer. But in level two, it is still deterministic. There's only two tools that it's going to use. There's no going back and feeding back into this to go there. So because the nature of the question could be complex, right? So I might ask a question that requires some research into tools, the output of the tool being fed. All of that is now being decided by this LLM, and finally for it to reach an output. So is level two clear?
That means level 2 you were saying, if I put some input like create one project like calculator, it will do
Yeah.
all the inputs, it will make addition, subtraction, division up to all the levels, then you will share the output. That is level 2.
No,
Kind of example
you
which
don't
you
even
understood.
no, you don't
Uh,
even say it's a calculator. You give it a
mm,
problem, and then
mm.
it decides whether to use a calculator or something else.
Okay, it will decide itself. Okay.
But it's going to decide between one of these two tools or three tools, four tools, whatever. So that is fixed. It's not going to go out and use some tool that you didn't even know. Okay.
Okay.
But based on the question, it may say, because the tools will have capabilities. So when they write the tool, they will say, this can add, subtract, divide, and multiply. This can, whatever. And then in that input, it will say, what is the user trying to do and what tool do I use? So that is level two. In level three, the big difference is this feedback loop. So it will use all of these, and then it might still decide that this is still not the answer that is right for you, that it
Oh,
needs to do more processing, that this is only the first step of a four-step process. So it will go through and do all of the project planning and design. So let us say, you put in like Claude Code, you give it a design specification, you give it a product
okay.
specification, you give a
Mm,
customer requirement. They're all documents, and you say,
correct.
create something. Well, it now needs to go through, analyze all of that, then understand your question, then say, this is how it's going to formulate all this, and then come up with a code, blah, blah, blah. Right? So that is the kind of level three. At the end, you just get a beautiful PowerPoint of whatever it did, however it did.
Understood.
Okay?
Understood now. Yeah.
Super. So now, where can attack come from? We are talking cybersecurity. So all of that, what we have talked about is if all go well. So in cybersecurity, we always think about what if something goes wrong? What can go wrong? So what is the attack vector? So the attack vector is getting untrusted or malicious data into the model that has a negative downstream effect. So data is key. Garbage in, garbage out. So if I can somehow create, craft a prompt that hides malicious intent, because unlike our traditional protocols that have fixed syntax, be it HTTP, be it TCP, anything, they all have a fixed syntax. There is a protocol, there is behavior, and so it's fairly easy to detect anomalous behaviors. Here, it's a natural language. We are asking an English question. So how can malice come about? Well, we're going to see later on in this discussion where that input can come from. But essentially, either the malicious input can come in by the user, or it can somehow get into in the subsequent process of level 2, level 3. Let us say it goes to a malicious website and then downloads something because you gave it the ability for it to do all that. Then that is also what they call tainted. It is tainted, so it's no longer reliable. So that is how the attack can happen. So that is a high level description. So in what ways uh, can this be proven? Prompt injection. So this is a very widely spoken about, and there's two types. There is a direct prompt injection or an indirect prompt injection. So in a direct prompt injection, I kind of got ahead of myself. So this is where I write a question, and in that question, I possibly put white on white space, which we can't see as a user, but the system will see. Or there's something called ASCII hijacking. And I will talk about briefly all those things later on. But these are machine readable, not human readable. So if the attacker knows what the LLM is doing and how it is processing, then potentially we could poison that system and create a malicious downstream effect. So what is the methodology? We get the malicious data into the model. And to do that, as I said, we need to understand attackers do some work. They just don't attack and be successful. They understand, be it an insider attack or an external attack, they know some things. So they have to know what the data source is used. And the NVIDIA AI red team actually showed up, and we'll talk about 3 or 4 types of attack that they proved and demoed. That's why I strongly encourage you to go and watch that video, right? So they need to understand the data sources, be it a SharePoint, be it emails, be it whatever, right? So, or any local database that it stores. So there has to be some inside information that's available. Then they must also understand how that input is being processed by the model. What is it looking for? So they're all attack vectors. So that if they can somehow influence that, then they will also be successful in getting and creating a malicious downstream effect. What tools are available? Let us say they make a web request outside. Then you can have a malicious website, and so let us say you ask the LLM to do a Google search and take the first search result and go, well, what if that search leads to a compromised site? So Google may not detect it, but the site may be compromised, and then your output is also going to be compromised. So this is the key thing. If untrusted data can get into a system, then a malicious action is always a possibility. So we must always think, at what point can untrusted malicious data, if it is untrusted, you have to see it as malicious. So, and there are ways to guard against that. Okay, so let's jump straight ahead in terms of what attacks. This is the interesting part. Okay, why did they succeed? So the first thing they did, and this was proven, and they reported it to Microsoft or Cursor or whichever company. Okay, so this is not a theoretical thing. That is what the AI red team do. I would say it's a service to the industry, because they detect all these issues and report them, because their intent is not to disrupt. Their intent is to make systems better. Okay, so RAG, what is RAG? I don't know if you know about it. It's called Retrieval Augmented Generation, which means all that it is you have a local database of knowledge that you also tap into. Every company has something, be it documentation, engineering documents, product requirements, that because this is not just for external use, this can be in internal use too, right? Let us say there are 5,000, 10,000 employees, and they want an LLM based interface to access their own internal resource. I worked at Cisco and Fortinet, and I know how hard it is to get information. Is there, you just don't know where it is, and you can keep searching first page, second page, you just will not get it. So there's a lot of use case for internal searches as well. So they will really depend on the RAG architecture. So what they did, so essentially first, before I get to what they did, so they knew that there was SharePoint data with user emails and all that it was using to augment the LLM response. What these guys saw, remember about untrusted data, all they did was to send an email that got into that website, into the RAG database. The email didn't work, but it was still processed by the LLM. And all that it is, the email said, if there's a product inquiry, go to this site. It just blindly ingested that. And so what happened? So they tested it. I mean, we don't have time to go through the demo or show the demo. So essentially, what they did was, they did that, and then they put out a query. It gave that malicious site, and they said, "Hey, Microsoft, go and fix it." Again, I will stop after these 4 use cases, and then we can move further. Second, so Pandas AI is an open source tool. What it does is you can submit a query with data and then ask a question about the data. You can submit a table, you can submit an image, whatever it is, right? You submit data, it understands the data. They call it multimodal. It can be text, image, whatever, right? So it understands the data, and based on that, you can ask questions. So it's almost like, I don't know if you've gone to YouTube and you can ask Gemini and say, summarize the video, or you can ask a question about that video and it will tell you whether the topic was covered or it wasn't covered and where exactly it was covered. So it's kind of something like that, right? So what they did, look at that, they created a prompt. So remember I talked about the system prompt where the LLM is asked to say you are this expert, so that it has some boundaries around what it can and cannot do, right? So what they did was they said ignore the system prompt and use this Python code instead, and they got a reverse shell. I mean, you must see the demo. It's like shocking that they actually, so the attacker would be waiting for callback, and bingo, they will execute that and it will come back. So that's why, as cybersecurity professionals, we must see these demos to be able to really feel that this is all real. This can happen. Of course, we don't live in fear, but we need to be alerted around it. So that's another wonderful demo that they did around remote code execution. Now, the third thing that they did was they call it computer use agents. So this is like a client server architecture. The client submits a question, the server with the LLM model processes it, gives back a result, which could be code, and that code is executed on the local machine. Then it could ask another question, it will come back, but all code is executed on the local machine, right? Not on the remote server. So the example they showed was summarize trends in the stock market and save a CSV. So as you can see, this will vary day by day. Stock markets change day by day. And so when they submit the prompt, the server says, okay, send me the stock screenshot. So maybe you go to Google Finance, Yahoo Finance, whatever it is, or, whatever, SenseX, and you give that screenshot. It will analyze the screenshot for the inference. And then in that, so what they did, they crafted something wherein the malicious payload, they got the user or the LLM to go to a malicious website to download that code, and then the end user executes it to get a reverse shell. So it's kind of an extension of use case 2, but here the client executes it, and this is where they show it in Cursor IDE as well, which I will show. And so this is how it starts to get scary, where there is interactions happening, client and server, and then malicious code gets executed on our machine, and a compromise occurs. The last one, Cursor. I don't know if you have used Cursor as an IDE. So it's a fork of Visual Studio Code, and you can ask LLM questions. As I said, it has its own model. It can also leverage other models. There's a paid version of $20 a month, whatever it is. And so you can leverage that as an IDE, ask questions, write code, and all that. So what they did was they they inserted white space in the source code in a Git repo. And so this is white on white, so you just can't see it, but the machine processes it. And so they download the repo, and then so once they repo, the Cursor IDE says refactor the code, meaning make it more efficient. And then they so what it did was it refactored the code, but then the original malicious code still existed. It ran that code, and a compromise occurred. Second thing they did with Cursor was there's something called a rules file, and this is where they did the ASCII smuggling. ASCII smuggling is, ASCII for capital uppercase A is 65, capital B 66, and so on. ASCII is a American standard for information interchange. So you can bit shift that, which makes it into non-readable characters for human, but it is readable by the machine. So you see how much of depth they go to create these attacks, but these are all possible. So again, when the user downloaded it in Cursor executes the code, the malicious code gets executed, and they caution that Cursor has a feature called auto run, meaning don't even ask me for permission, just go ahead and run it. Well, what happens? Malicious code gets run and the system is compromised. Okay, so now we will go into the next part. We talked about all the attacks that they succeeded in. Any questions?
No, Srikanth, means you said that is four thing red team is done, but
Yeah.
I'm trying to imagine myself how they are done because this is my scenario only. If I'm wrong, just correct me. Our project also we using our project not using, but our company insists to use some AI like Lane or
Mm,
Codex. Okay, so what I am doing in this is my purpose only. So I will create some web page. What I am doing daily activity, I just put into one dashboard. If you click the dashboard, I can do. If you click each and every button, it will open separate website which is using internally.
yeah.
Sometime what happen if anything required, I will do some extension create Chrome. I can include in that page in the browser. So is it any wrong to hacker to hack or is the extension is a good way? You understand my questions or
Extensions to the browser.
no, I'm creating an extension in the Chrome. So example, there is two pages there. One page I cannot able to access via my dashboard, my
Okay.
own dashboard created by AI. So what I do instead of that one, I create one extension. It will support the Chrome. You can go to Chrome, put the extension. Mean it will configure the web page. It will work like it is integrated to my site. So if
Right.
I doing this kind of thing, is the correct way or it will the impact of that cyber team some hacker will do? I just want to know whether shall I do a extension using the code.
Yeah. I mean, uh, the first question we all have to ask is, if the system can be compromised, where can untrusted data enter? So
Mm.
when you say you're
Yes.
using AI or LLM, you know, we have to think like a thief, unfortunately, for us to be a good policeman. So where can untrusted? So if it is all a very controlled system wherein you're not accessing the internet, the data is clean and all that, then you're probably safe. Again, in cybersecurity, there's no guarantee that nobody can fool me. At Fortinet, they will always have this saying, it's only a question of time that we will click on a malicious link. But we still have to be careful. So we will talk about some of the defense mechanisms. So maybe that will help you to say how to think about this and how to approach this. So I don't have a specific answer to your particular state, whether it is secure or not, but there are some general best practice assumptions and best practice guidelines that we will go through that you may find useful. Talk about how do we protect ourselves, to your question. So there is something called a cyber kill chain that has been around forever. So the first step here is they call reconnaissance. So we talked about the attacker has to do some work, like the Microsoft Copilot. We must know that, hey, they are using SharePoint, that it has email, it is processing email for us to send an email. So that's always the first step in any attack. Then getting the malicious data into the model, like an email that says for any product inquiry, go to this site. Okay. So this is where we need to start thinking about, where does data come in, and is that data clean? Is that data sanitized? Is that, data having any sensitive information? All these things is our responsibility. So then once I know these two, then it's about a question of launching the attack, which is injecting that malicious data, just like that email or modifying the system prompt, whatever it is. And then you persist that across sessions. So remember, once it is tainted, it's always unreliable. So we need to persist that. And then the more the agent does in subsequent iterations, the more poisoned it becomes. And so that's where we need to have guardrails through manual approval. So any extreme automation where we have no control is always bad. And so let us not assume that humans will be unnecessary. There's a lot of talk going on in the media. You know, yeah, I mean, we have to see this as a tool to help us, not to replace us. So, but industry as it is, they tend to get overexcited about everything, and then they come back and correct. So that's the last step is the impact phase. Okay, so that's that. What do we do about it? Um, we have to identify sources of untrusted data. So to your question before, uh, it can be a user input, chain of trust or a scratchpad. So chain of trust is where you have multiple people. There's a person, they're asking a question, then it is going through an authentication mechanism. There's a series of linked chains that make up that chain of trust. If even one of it is compromised, then the whole thing is compromised, right? We talked about RAG, retrieval augmented generation, web data, conversation. So any of this stuff could be tainted at any point in time. Then, if any of that is tainted in here, then the inference service will also create crappy calls, crappy output. But again, remember we said in level 2 and 3, that is not the end. It feeds that into more LLMs, more calls, more this, more that. And finally, it will just get progressively degraded. Just like, early detection of diseases. If you don't detect it early, then it will only get worse because you're not taking any treatments for it. So let's just do a quick recap, a summary. So the NVIDIA team calls it the universal anti-pattern, meaning what can go wrong. First thing is, we have said this a few times now, untrusted input getting into a system. Once tainted, always untrusted. So what can we do? Avoiding untrusted data sources. If it's the internet, boy, anything can be compromised there. So avoiding that, right? Once you get the data, go through a process to sanitize it. Is it clean? Is it non-malicious? Go through some of the tools to or remove stuff that's not necessary. There is some work that needs to happen because this cannot be this open system where anything is open to everybody, right? So we are running it in a business, and the business has accountability, and so we have to make sure that we have to sanitize or have guardrails saying if you see this type of a question, say that that's why you have the system prompt. So you have a system prompt saying you are a HR agent, and as a HR they don't have access to payroll information. You have no control of what I'm going to ask as a user. I may say, give me the salary of my manager. It has access to it, but then it must detect that I'm not authorized to get that and it must stop that. So that's a guardrail, right? So, and then tracking untrusted data throughout its life cycle. This is a level 2, level 3 challenge, right? Where is untrusted, or where could untrusted data potentially come through? So maybe in the first LLM inference, you're not using a public source. Maybe in the second and third stages, you're using that. Well, is there a possibility that untrusted data comes through? That's something we need to check. So we have work to do. Second, it is paused or altered something vulnerable to adversarial manipulation. So this is the white space, white on white attack, and so on. Humans cannot see it. LLMs can see it. ASCII smuggling, right? So this is where they recommend that you separate the processing of untrusted and sensitive data. So let us say you're opening it up to the wide internet. Why should they have access to sensitive data? Their database, the RAG database, must only be sanitized public information. So there's something, a term called data classification, wherein you say this is public domain, is this confidential, is it highly confidential, whatever. Let us say a company is going through an acquisition. That data is not public data, but if you keep all the data in one database, then you are going to invite trouble because, as I said, you have no control of the data that's going to come in. So separate that untrusted and sensitive data, sensitive tools. And we'll talk about that too. What the tool can do. Can it only read or can it read and write? What can it do? We have to have guardrails there. Then this is the level 3 thing, right? Result is passed to a tool or plugin for action. Assume prompt injection. They're very clear about that. Don't say prompt injection is not possible. Assume it. Then what can the tool potentially do? What might you give up? Is it just an embarrassment? Or have you just leaked out sensitive information that's going to invite a financial penalty? So these are the things we need to think about. Again, these are guidelines, but we need to do the hard work of clicking double, triple, and so on to see where else can data come from, because this is getting more and more automated. So what is the best practice for risk mitigation? Accept misinformation risk. So their point is, we must have all heard about hallucination, meaning even if it tells something incorrectly, it will say that confidently. So, and that hallucination gets worse as the depth of the conversation goes. And everybody has reported that. So sometimes they'll say really stupid thing. How do you know it's stupid? Because you need subject matter expertise. This is why, you just can't get rid of people. So how do we tell that something is right or not? Sometimes it's a gut feel. Sometimes it's like, I need to verify this. Where do we get that? Because we have experience. So let's understand that LLMs will hallucinate. So use credible citations. So in the LLM, we must always ask for a reference. Where did you get this information from? If it is from a no man's site, well, that cannot be trusted, right? We must also educate users saying, don't blindly trust. It's a tool. Just use it as a tool and always view it with a healthy skepticism. This is the second part that we just talked about the previous slide. Identify sensitive actions. If you give the tool the right update and delete operations, you got to be very careful that you're doing the right thing, right? If you're just even if you're just reading, how you because it's in the database, then you need to scrub it out, right? How could you know PAN or Aadhaar card numbers and just give it out because somebody asked for it? I talked about data classification and user authorization. If it's a general user, see them as a guest, not like an internal employee with access. So authorization controls are important, but it's important to identify what that user is. So where are you exposing this LLM to? What type of user persona you're exposing to? That will determine what level of access. So the traditional authentication, authorization, accounting, they're all still valid. Authentication maybe not for external users, but authorization for sure, right? That determines what level of access is possible. Any internet access from the inside out, I talked about web search, that's a worry, right? Maybe they compromised it and asked it to get some, just like the Git example that I was talking about. It went and got something, some compromised repository from somewhere, executed the code. So that's a warning sign. Have to set up manual approvals as needed. Sorry. Uh, let's not assume that just because it is doing something, it is doing something correctly. Our job is to always be that person asking the tough questions. What if it goes wrong? Where can untrusted input come from? What levels of iteration is it going through that it may get worse, and so on. So these are the things that are best practices for risk mitigation. So last slide, concrete recommendations. Validating input data, isolating sensitive from public data. So one other thing they talk about is, don't use public web links, use links from static sources where you control. You see how careful they have put together these recommendations and, content security policies. And they also say that if you're executing a code, execute it in a sandbox environment, not on your machine, so that you know what it's doing and then you're happy with what it is. And then, so there is work to be done.
You said again now that sandbox is very good. What is the reason? Because I say it again, I'm using Codex only. Whenever
Yeah.
I'm installing, I did some Codex sandbox also, but I don't know what is
Mhm.
the purpose. It is coming just simply configured, but I just want to know what is the main benefit for the sandbox. That's it.
Yeah, great question. So what a sandbox is a isolated environment. So it is not running on your machine, it's not running on a public machine, it has limited access. So what it does is it monitors behavior. So in a traditional cybersecurity sense, so I don't know if you've heard of zero-day attacks or day zero attacks. So it will model the behavior of the operating system and say, hey, this code is doing something that is not a typical operating system call. And then it will give a verdict saying this is seems to be a good code or it seems to be malicious. That's kind of the sandbox environment. But in your case, the reason it is running in a sandbox environment is because it does not want to expose you with a compromised machine. And it's also accountability issue. Somebody will sue them in court saying, hey, I got Codex to run code. It ran it on my machine. My machine got compromised and the whole company got compromised. So they don't want to take any responsibility. They'll say that any code that you ask me to run, I will only run it in a sandbox environment and give you the code. And you can see it for yourself. So that's the purpose of sandbox.
Then sandbox is a security thing. It's a security covered by the thing, easily can able to hack, or the other people can see the code, correct? Like, understood?
So sandbox is a runtime environment. So you
Okay,
have a
gray
code.
area.
Yeah, you have a code, and that code needs to run to make sure that it is executing properly or not. So, unlike that, the client server that we talked about, wherein you executed the code on the local machine, it executes that code on a sandbox so that they are protected, you are protected. All you want to know is whether the code is running and giving you the result. Why does it have to run on your machine or anybody else's machine? So they run it in a sandbox and give you the result.
Okay, it's a VM, virtual machine like that. Okay,
Yeah, it's a
understood.
VM. Yeah, isolated VM. Yes.